Kajal, we have a question in the chat board. Like, it is like a theoretical base, or it will be having some kind of demo also.
Uh, One second, I'm opening my chat. So it will cover both the things. There will be a demo as well as some theoretical concepts also will be get covered. Uh,
Yeah, sure. Okay, so good morning, everyone. First of all, like, thank you for being here and attending this event on weekend. So it's a good thing for us also. Like, you guys are supporting us for this event. So today we are going to like talk about monoliths to microservices. Like we are making the shift. So Kajal Rana will be presenting this session for next 1 hour. And this session will be recorded and uploaded on the YouTube channel of Surat Tech Community. I will be sharing the link of that channel into the chatbot also into the chatbot also. And the link is available on the Surat Tech Community meetup group also. So before we start with the actual session, I would like to encourage each and every one to be an interactive. And if you guys are having an interest in delivering a session virtually into this community, then please reach out to us and we will arrange a session for you guys also. It is not like we need a limited speaker. We will give a chance to each and everyone, whoever wants to present themselves with any topic. The concept of the Surat Tech community is like just to spread the knowledge, like learn, share. So like we just need to share the knowledge on whatever topic that you are in expert in that field. Initially, we started with the Copilot. Initially, we started with the Power Platform data flow. Then we shifted to the Copilot. Then we had a SharePoint agent. And today we are having completely different architect level topic like monolith to microservices. So in future also we will be making this kind of shift. We will be jumping here and there between the topics. It's not like everything will be covered that is related to the Microsoft or SharePoint. It will be like mix of all kind of product and mix of all kind of services. So if you are interested in delivering a session to in the Surat Tech community, we are open for everyone. Just send me the details on LinkedIn or I will be sharing the detail of a communication detail or contact detail of Surat Tech community at the end. Or I will be adding that into the chatbot just after a few minutes. Then if you have anything to discuss, if you have any question, if you need to deliver a session, if your friend is interested, then also we are welcome. So please join us and please submit a session if you need to talk about. So with that, I am handing this session to Kajal. So please continue, start with your brief introduction, and then let's start with the session.
okay. Thank you, Akash, for giving me this opportunity first of all, and thank you everyone for joining this session on weekend. And hope you all are doing well. And so going to my introduction is like I am working as a senior software developer at Value Labs in Bangalore, and yeah, I am basically from Surat only. So I when I got this opportunity, so I was overwhelmed that I like we all should contribute in growing our Surat tech community. So yeah, this is a great opportunity. If you guys are also uh, want to grow the tech community, grow yourself, we should all take part in this sessions and deliver the sessions. And today, like you all know, today's topic is monolithic to microservices, making the shift. We will cover the concepts of monolithic, concepts of microservice, how we can migrate to monolithic to microservice, what are the standards we should follow. We will also cover some technical part, also like practical, we will also do in this session. So yeah, this is going to be a fun session, I hope. Akash, can we start?
Yes, you can start just 1 minute. If one disclaimer, like if any one of us get disconnected from this call, please allow us 3 to 4 minutes to rejoin because it is a technical and it's an online. So sometimes it happens the teams got went in not responding mode. Sometimes the internet connection get disconnected. So if we are like breaking into the session, then allow us 2 to 3 minutes to rejoin. Yeah, Kajal, now you can start.
Okay. So yes, starting the session, we are covering monolithic to microservices. This goes my introduction, like we are going to understand the monolithic first, then microservice, then all the related topics to monolithic and microservices. Uh, so let's start with monolithic first. So we all know that monolithic is kind of our code in a single repo, like all kind of code, business logic, database connection, UI, um, any other connection, cache connection, Kafka connection, all will go in a single repo. That is what monolithic architecture means. So monolithic architecture is generally adopted in the early stage of the project, where I can say it's a very start of the project. Things are less, or we can say that monolithic architecture is getting adopted where the project growth is not that rapid, where features are not getting into in very faster phase or anything else. So wherever you are using a monolithic architecture, uh, there are some components included in it. Let's say there is a UI interface we are building. So for that, there will be a monolithic repo for React as well as for front end as well as back end. Front end will cover the UI part, back end will cover all the business logic and the database connections. So we will going like in that way, that we have a front end and back end repo both in the monolithic architecture, and we are assuming that we'll build an e-commerce web application. So we'll see what components will be covered in that. So there will be user. So as we are building a e-commerce web application, what we can assume our core functionality is we will have a shopping cart, we will have product catalog, we will have a user management system, we will have order processing, we will have some database connection, cache connection, other libraries as well. So all those components we can include in our monolithic architecture while developing an e-commerce web application. So now we are talking about a monolithic architecture. So we will build a single repo code base where all these things will get included, and all the components will be tightly coupled with each other. Now when I say tightly coupled with each other, meaning that they all will be interdependent on each other. uh, Say be it front end code, be it back end code, all will be there in a single code base. Now when we see a project or a repo, on what basis we can say that it is a monolithic? First is the same code base. Second, will it has same connections to database. Third, it will have same CI/CD pipeline to it. No other deployments are going on. Only on single deployment our whole project will get deployed. And if if our one module is getting affected, say a database connection, database is getting overloaded, or our API is getting slow, uh, our whole system will get affected due to that, because it is a tightly coupled architecture. So it is not something like that only we are adopting the a monolithic architecture. There are some big brands which on their early stage have also adopted the monolithic architecture. Say Amazon, Netflix, Uber, all of them have started using monolithic architecture, and gradually they have shifted to microservice architecture. We'll cover that in another slide. But say a real life example if you want to take, of monolithic architecture we have here as Amazon. So Amazon has, you all know, Amazon has so many things on their UI, on their backend part. It will, I'm sure there will be much more on the backend part as well. So on the early stage of Amazon, they have started as a monolithic architecture, uh, which started to grow on a very large scale as Amazon has grown to a big giant now. So we can see, we can take advantage, like where we can use the monolithic microservice architecture. So what are the key insights of monolithic architecture? uh, Whenever it comes to a monolithic, there are some pros and there are some cons also for the monolithic architecture. So we'll cover first what are the pros of using monolithic architecture. Sorry. So let's say I am a very beginner in this IT field. So starting of my job, I won't be directly jumping to microservice. I will first go to monolithic architecture because it is very simple to develop, very simple to understand, very simple to deploy. And as we all know that testing and debugging is a uh, main thing to have in our, especially in backend code. Front end has their own automation tools, but when I talk about backend, it is very much tedious as well as very much important to have test cases in it. So so I can say that if I am using monolithic architecture, my testing and debugging will be very easy because I have to only see a single repo code base. I don't have to jump in different repos to debug any important P0 bug, or while doing any testing, I don't have to connect different repository to make an API to run. So that is one good thing about monolithic architecture. And where there is a startup or where we are building a small project, monolithic architecture is definitely a uh, good thing to start with. Whereas we have some cons as well of monolithic architecture because uh, we can't say when our project will grow, when things will start getting to fail. So there are some cons as well in monolithic architecture. So what are the cons here are, it is very hard to scale individual parts. So as we saw that in our product, in our system, there will not be a single unit delivering the things as a product. There will be multiple components which are contributing to a product to work. So let's say I have a user processing unit, I have payment module, I have user management. So all this, if all these are interconnected and my order processing component is lagging in this performance and I want to scale that particular component, I won't be able to scale that much because all the three things are very tightly coupled in a monolithic architecture. So where it comes to scaling, monolithic architecture becomes a tedious work. and and now there are many languages coming in with very new features, very good features which we want to adopt as in our system to make it perform in a good way. So when we are using a monolithic architecture, it's a single repo. We can't use multiple language in a single repo. So if we want to write some code in Python, some code in Go, and some code in Node, we won't be able to write in a monolithic architecture because it's a single code base. So if we want to adopt new technology, if we want to do some POC, it becomes a very difficult for a monolithic architecture to make the changes and make it very quickly. So this all are pros and cons of monolithic architecture. Uh, Now it all depends on how we want to use monolithic architecture. We want to use it or no. It all depends on our use case and our project structure. So here you can see the complete difference of monolithic and the microservice architecture, where here monolithic, all the things are there tightly coupled with a single database connection, whereas a microservice architecture has a individual database connection to individual microservices. Again, this database connection to a different microservice is optional. It again depends on our use case. We can connect a single database to a microservice as well, uh, where we can use a different database as well. All depends on our project use case. Now, coming to microservices, what microservices are, why we should use microservice, we'll cover in this section. So, uh, like now we got a complete idea from this picture that what microservice actually is. What microservice actually is to break our monolithic architecture into a different component, where we have to find what are the main components in our monolithic architecture. Say if I give you an example of Amazon. So Amazon has order processing, product catalog, payment, search engine. So all four things are a main backbone of Amazon, we can say. So if I want to break Amazon's monolithic architecture, I will figure out that this four components should be in a different repo altogether, no matter what. So I will break those four components into a single individual repo. One repo for order management, order processing, one repo for payment processing, one for search engine, and one for product catalog. So likewise, we can convert a monolithic architecture to a microservice architecture. Now, now we know that how we can break a monolithic to a microservice, but why to break is a question. Say, like I covered it earlier, that if we want to scale our system in monolithic architecture, we won't be able to scale. Whereas in a microservice, if I have a different order processing system in a monolithic and in a microservice architecture, and if database is getting overloaded, or my order processing is getting failed, I can easily debug and scale in microservice architecture, because I have a fully at full access on that particular single component. Whereas in monolithic, I have to see what other dependent things could affect if I change anything in order processing system. So here comes why we should use microservices. First is to scale, when very easy to update and maintain the microservices, because again it's a individual repo. We can do anything to the individual repo without affecting the other components of our product. Uh, so if we are using a different repos, obviously the development will be different, the deployment will be independent, that scaling will be independent, that problem solving will be independent of each other, their solutions will be independent of each other. So we can focus on a single service specifically. And there is one more uh, good thing about microservice is it allows to grow our development very fast, because it's a separate microservice. So we won't have to wait for a feature to develop, and then we can add more features, dependent feature. We can add features in our microservice, and parallelly we can add features in our different microservice as well. Let's say if I have to add a feature in order processing, we have to add a feature in product catalog. We don't have to wait for anything in microservice. We can parallelly develop both the features. And wherever and whenever we want to uh, launch our feature, we are ready to go easily, without any blocker, without any dependent feature to get deployed first. So I'll quickly go through the points. Are microservice architecture is designed to address the challenge that monolithics can grow. It is by breaking application into smaller independent service to scale, update, and maintain the system more efficiently. And each service can focus on a specific functions, such as authentication, payment, order, and can be deployed, developed, and scaled independently. Whereas with microservice, team can deploy update to one part of the application without needing to redeploy the entire system, because we will have a separate CI/CD for each of our microservice. And it enhance microservice enhance more resiliency, because if one service fails, the rest of the system can continue running without reducing the risk of full system outage. So here this point says that if my one microservice is failing, the whole system will not get affected. But how to mitigate that one system failure? Even that system failure will affect us a lot in many terms. So there are different ways to mitigate that failure as well. We'll talk later in the slide that how we can we can one second. So there are multiple ways to mitigate that failure in microservice. We'll cover that in the later part. Now moving on, how, like, what are the industry standard strategies for moving from monolithic to microservice architecture? So these are the three very common and very famous pattern that usually big companies are following. First is triangular fig, second is incremental refactoring, and third is parallel run. So starting with the strangler fig. Strangler fig is something that we have a monolithic architecture. We want to convert it into a microservice. Will move one feature at a time. Will not completely shift it to microservice. Will gradually keep moving one features at a time, test it, deploy it, and see how it is behaving in the real world. So this is a strangler fig pattern where you can see these are the monolithic architecture and this is the microservice. So as we move our monolithic services to a microservice, breaking down it into a microservice, the monolithic uh, code is getting reduced and reduced. So this is how we should usually do the shift of monolithic to microservice architecture. Second is incremental refactoring, meaning that we should first uh, identify that what all components we should move first, which can improve our system drastically. We can improve that, we can refactor that part first in our monolithic, and then we can entirely move that system. So when I say we can refactor in monolithic, I mean that if that component, say order processing, is there in my monolithic architecture, it will be very tightly coupled, will be very dependent on other parts as well. So we have to make that part first independent, and modular code are generally more useful to shifting from monolithic to microservice architecture because they are easy to shift, and we can move it to different repos. So we have to first make it independent, and then without affecting other code, we can directly move it to our microservice architecture. So here you can see that this is my API gateway. This is inbound and outbound. This is event publisher. Any event publisher we can use. And this is my old feature and my new feature. Now on API gateway, we can configure that if my API is there on API gateway, I can configure that if I want to make this API call to my monolithic or my microservice architecture. So that basis on that control, we can move, we can divert our API to whatever service we want to do. So after testing, after regression, after performance testing, we can start using the incremental refactoring pattern in our new service and divert our APIs slowly to our new microservice architecture. Third one is the parallel run. Now, parallel run are generally used where we have so there will be business requirements as well we have to complete. There will be other tech tests also which we have to complete. So parallel run is kind of a technical refactoring, I can say, where we are developing our business requirement. Parallelly, we are writing our microservice code as well. So in here, we are not we are not reducing our monolithic code and moving it to microservice. No, in parallel run, we are building our microservice from the scratch. So you can see here, one is our monolithic, one is our microservice. Both are a clone system, and whenever we are ready to launch this microservice, we can divert the request to our new microservice rather than making the API call to a monolithic system. Here in parallel run, results will be same. We just have to compare our monolithic results to a microservice result to test whether our microservice are running well or not. So this three are the strategies to to migrate from a monolithic to a microservice architecture. Now, if we are migrating this big system into a microservice, we should follow some best practices to not make our system fail very badly. Failure will be there, but we should be ready to mitigate that failure, or we should migrate in that way that failures will be as minimum as it can be. So these are some best practices we have to follow for microservices. First of all, in monolithic we have that ease to debug and test things very easily because it's a single repo code base, whereas in microservice the debugging part become a very tedious, not very, a little bit tedious work. So we have to design, first of all we will have to design a failure, like if my microservice is not working, what what fallbacks should I keep for my microservice. So there are two, three very common and very well known design systems are there for failures to mitigate the failure. One is to implement retry. Say my API is my internal API, which is calling to some third party API, is failing. So we can keep a retry, a minimum 3 or 5 retries we can keep in our microservice. Second is circuit breaker. Circuit breaker is a whole different topic, a very vast topic where it's like a trip switch where if something is failing, it will stop the incoming request to the microservice, so that it will the microservice will not fail more, it will not go worse than that. So circuit breaker is a very important uh, part of our design failure. So we should always have a circuit breaker or a fallback mechanism. Say if my order processing is failing in microservice, I can immediately move to our monolithic architecture or something like that. We should always have a fallback in our system. Second thing is single responsibility. Now, as we are moving to monolithic to microservice, we should not uh, give a single repository, a single microservice, multiple responsibility. Say if my order processing is a microservice, it will only do order processing. It will not validate any users. It will not validate any product catalog. It's there are other repos to do all these things. So a single repo should have a single repo responsibility only. Third is API first approach, where uh, where we have to design first the API signature, that which repository, which data I need, which API I should call, how many API calls I have to make, because it's a independent microservice. So we have to first define our API structure. Signatures should be logged before starting the development when you are working as a microservice. Fourth is automated testing and CI/CD. Automated testing and CI/CD will always be independent in microservice. If every microservice has its own CI/CD part, and automated testing also, it's an optional thing. We can keep it. We can we can do our automated testing in a whole separate uh, repo where all the microservices are getting covered. We can do automation testing using Playwright or writing some test cases. So it's up to us how we want to do testing of our microservice. Uh, Fifth is decentralized data management. Now, this is again depends on our use cases, how our microservices are built, uh, how our project is structured. We can decentralize our data management, or we can keep it as a single source of data. We can keep a single database connection as well. Um, Sixth is monitoring and observability. Now, if I talk about microservice, debugging is very easy, but again, to find the root cause in microservice is bit tedious. We can see what things are going on in individual repository in the microservice. So we have to implement our loggers and our monitoring part in that way that we can quickly and easily can get the RCAs of the bugs. And seventh is versioning. We if if you are transitioning from monolithic to microservice architecture, we have to make sure that backward compatibility is there. Even in monolithic, I will say that we have to ensure that backward compatibility should be there in the APIs. Without that, uh, we cannot develop a new feature, because if anything is uh, let's say where versioning is will help us. Let's say I have a mobile app and my APIs, I am improving my APIs or adding a new feature in it. So how mobile application work is uh, uh, we have to up, send the updates to the user. Now, if user is not updating the application, my application still works in a older version of the APIs. And here in my backend repo, if I am making it to a newer version without backward compatibility, the application is going to fail. So we have to ensure that backward compatibility of the API should be there. Now, coming to some real life examples of big giants that adopted the microservices, as I said, that Netflix, Amazon, Uber, all these are very famous examples of a microservice architecture. So even Netflix has also started with a monolithic architecture. So if you know about the about history of Netflix, I think in 2002, in 2002 or earlier, they have started their business by distributing the DVDs, and their business grows. And 2008, their business has hit the threshold that they were not able to uh, manage their system because they got so many of users. Their user base was growing and growing year by year. So by 2009, they decided to shift from monolithic to microservice architecture, not in one go, bit by bit, and they moved their monolithic architecture to a microservice architecture. So here you can see in 2009, and they have used AWS as their backbone. So in 2009, they have started using CDNs for content because their user base was initially in 2002 or earlier, it was only US based user base they have. But by like year by year, they have started gaining their popularity all over the world. So they have started using CDNs and EMRs and business intelligence. By 2010, they have started using CDN routing. 2010, they have also started some other features they have started in the microservice. Now uh, they have shifted to a microservice. They can add more features easily. So they have added this rating, movie choosing, because earlier they were only selling the CDs, and in 2002 they have started selling the CDs. 2007 they have launched their CD catalog on their website, and in 2010 they have launched the movie choosing catalog where we can easily choose which movie we want to see. So likewise, Netflix has uh, developed their microservices from a monolithic architecture using AWS. They got so much support from the AWS because it's a growing business. So they got so much support from AWS. They have used AWS services, and they have moved it to a microservice architecture. I think we have a question here. I can directly see the question. Can we deploy each microservice in different? Yeah, we can deploy each microservice in a different cloud provider. So that's the beauty of microservice. We can independently develop, deploy our microservices and scale it independently. I hope I answered your question, Murugan. Another famous example is Uber architecture. So initially, Uber was also a monolithic service where you can see REST APIs. Adapters, meaning here are the customer, drivers, payment service. All these are adapters here. Database, all these things are in a single repository. But when they start gaining the user base, they have shifted it to microservice. So here, if you can see, there are different microservice for payment, driver management, passenger management, trip management. All this helps a lot to Uber to scale their architecture in a whole different way, and now they are uh, obviously gaining in the business and growing more in the world. So by seeing all these things, I can surely say that microservices has faster deployments, improved resiliency, better user experience, because we can scale it as much as we want and how we want. So while choosing a microservice architecture, it's very important whether you want to move it or not, because it is unnecessary, because maintaining a microservice is not that easy. But if your project is growing, you should always go with microservice. But if your project is of small size, your monolithic architecture is a best way to start with. So we have to see all the scenarios, how we want to migrate to microservice, whether we want to migrate it or not, and in how many releases we have to launch our microservice. All those things are very important if we are moving to a microservice architecture. Now, as I said, which is better choice, monolithic or microservice architecture? I like to think we have another question. Is it possible different microservices can have different tech stack? Yes, Anshika, it is absolutely possible that we have different tech stack for each microservice. I'll show you in a bit. I hope, Anshika, I answered your question. Mehul
Yes.
also. Oh, thank you. Mehul also have a question how microservice communicate with each other. I'll show you in a bit. We have a practical session as well, Mehul. So, which architecture to choose for our project is depends on first size and complexity of the project, as I said, and team size and expertise also matters a lot, because if you are breaking your monolithic in like so many number of microservices and team size is small, then team will not be able to manage and handle those microservices. So if team size is small, monolithic architecture is best way to start with. And expertise also matters, because system designing and have to uh, break our microservice to work with each other, to orchestrate with each other. Those expertise are very much needed if we are going with a microservice architecture. Third is scalability and agility. Scalability, as I said, it is very much scalable and very much adaptable if we are going to microservice architecture, and operational complexities will be also there, uh, because if we are breaking the breaking our repository in a different individual repository, additional cost will be there, infrastructure cost, resource cost, cloud cost, all will be there. But in return, uh, the microservice architecture will support you a lot. So here comes how microservices communicate. So there are multiple ways we can uh, make microservice communicate. First is, let's go through point by point first. When we are talking about monolithic application, we said that communication in monolithic is inter-process communication, where it works on a single process and it just invokes methods. Whereas in microservice, it's a distributed environment, and communication between the services is inter-service communication instead of inter-process communication, because each service has its own instance and process. So these are some ways. the microservice can communicate each other. One is HTTP, a normal API call of between the microservice. Second is gRPC, and third is brokers AMQP protocols. So we are covering HTTP and brokers AMQ protocol in this session. gRPC is a bit complex thing to integrate. So we are covering here only HTTP and message brokers. So here in microservice communication also there are two types of communication. One is synchronous, one is asynchronous. Now you guys should already knows what is synchronous and what is asynchronous. Synchronous meaning it will wait till the things is resolved, and asynchronous meaning we just trigger and we forgot it. We are not waiting for anything else on that. So here in microservice, asynchronous communication means we are we are talking uh, to to other microservice using a HTTP call or a gRPC service. So microservice is at the end individual repos has individual APIs. So we can call each microservice using an API call that we use generally. So here you can see there's a client, there's a basket, there's a product, and pricing microservice, order microservice. All these are microservice and they are talking to each other using HTTP call or gRPC. So this is an synchronous communication. We have a question from Arvind. Should a new project consider start off with a microservice model? Arvind, it again depends on your project complexity. If your project is uh, very small in your starting phase, we should go with monolithic architecture instead of microservice. And if you are sure that your project is going to scale a lot in future or a nearby future, then you should go with microservice architecture from the starting. But you will have to make sure that your microservice architecture is very well designed so that it is easy for you to uh, uh, add things, debug things in that. I hope I answer your question, Arvind. Yeah. Okay. Thank you. So moving to asynchronous communication, asynchronous meaning we just trigger and forgot about it. So that is the asynchronous communication. And so here you can see there's a client, there's a microservice, basket, product, pricing, and order. And in between there's a queue. Now this queue can be Kafka or Azure Bus or any kind of queue we can put in between the microservices to communicate with each other. So the very famous protocols we generally use is Kafka and RabbitMQ. So here in our session we are going to cover the Kafka based communication. While working with this queue, you have to be sure that you won't block the thread by meaning blocking the thread meaning that you should not block your system. You should not write any such code that it goes in an infinite loop or infinite processing. It should not be like that because it's a asynchronous. We won't be able to know that something is happening behind the scenes. So you have to be very sure while using the queue that you won't block the main thread. Okay, now let's go for the demo. I have two services here. I'll just open it side by side. This is just for the demo purpose. So I have made two services. Let's say I have uh, one service in Node and one service in Go. So here the right side application is in Go and my left side application is in a simple express node application which is running on 3000. Now, uh, as I said that we can integrate our microservice in any language possible we know. So here is Go and here is Node.js where here I'll show you the controllers I have. One is, let's say, go with a basic user controller. We have two controllers here. One is get user by username and one is a create user. Now, if I let's say we have we'll go first in a synchronous way how we can uh, communicate with each other in a synchronous way. So let's say if my node application wants to create a user using this Go application, what I'll do is I'll simply make a route in my node application which will indirectly call my Go application. So we have our env5. We can add the Go API here, the host, something like this. We can add, and here this is my business logic. Here I can directly call my Go API using this HTTP protocol saying that this is a synchronous communication. So what I'm doing here, I'm just calling create user API from node service to the Go service for creating the user. This is how microservice looks and this is how microservice works using a synchronous manner. And now if I show you the asynchronous manner with Kafka, and I will give you a bit idea of Kafka as well. So we all know that Kafka is a queue kind of thing where we can uh, produce the event and consume the event. So if we are using Kafka in our microservices, we should have a producer, we should have a consumer here, or vice versa, based on our use case. So let's say if I want to create a user using Kafka, what I'll do first is I'll integrate my consumer and producer in our system. I will uh, create a Kafka instance, consumer and producer instance in both the services because it's very much necessary to have a Kafka in both the service to communicate with each other. So here you can see that I have consumer getting connected on the given topic with group ID, with the brokers, and same thing should go in our dependent microservice that it should have same broker, it should have same topic, and it should have subscribed to that topic to consume the events from my microservices. So if I can show you, I am running my Go architecture and here I am running my node architecture. Here you can say that Kafka consumer is listening, and if I want, this is my node API which I am trying to create a user using Kafka and sending the event to the Go application. So if I hit here and check in the terminal, I can see that my node microservice has sent the message that say, hey, create a user with this uh, details, and I have sent the message to this topic. Now, what my Go application will do, it will listen my event saying that, hey, I received this event. for this details, and I have received the event from this topic, user topic, because I have sent it from the user topic. So like this way, we can communicate with our microservices using asynchronous way. Uh, yeah, I think and once the processing, see here, the API is getting processed and processed. So we should avoid all these things in our general development practices. So we should return anything from here while writing the code. We should not make it keep it processing and processing so that our main thread will get blocked and the whole system will get affected. So yeah. uh, this all are the concept of microservices and monolithic architecture. Why should we use, when should we use, how should we use, how should we communicate with the microservices? All these are the concepts that we have covered here till now. And yeah, if you guys have any questions, please ask. Or if you want to know more any topic in this session, we can continue this as well. Yes, Murgan.
Hi, Kajal. Am I audible?
Yeah, you are audible.
So actually, I missed some points in Kafka. Just want to know, because in each service we will have different endpoints, right? Suppose for a user, I will have get user or update user or delete user. So how does the Kafka communication works if you have different endpoints in each service?
So if you have already endpoints, you will also have handlers of that endpoints. So if you want to use Kafka, instead of calling endpoints, you can directly call the handlers of the. Uh, so if I can show you here in my Go repo, I am consuming the message here. So what I can do here is, if whenever I am getting message on the topic, I can directly call the handler here. You create user handler, and this will directly go to my business logic and creates the user.
So we have to map something, right? So
Yeah,
if
we
it
have
if
to.
it comes as create user, we have to call the create user handler.
Yes, correct.
So
Um,
what is the advantage of this than the synchronous communication, like calling with the port, directly calling with the HTTP endpoint?
so so generally, Kafka is being used for not for business logic. It is generally used for, say, I have to create a report, or I have to send some
Yes.
update from one microservice to other microservice to
Another
update. Mhm.
is
Say I have my order processing microservice, and I have user management microservice. Like now I want that my order should update to the users. So instead of calling the API, wait for that, I can simply trigger a message that, hey, this order is got placed by this user. We can simply trigger the event, and the event will do its own work. We don't have to maintain the other part of that thing. So in those things, Kafka is
but
used for.
one more thing, like just want to know, we have triggered the event. Whether how can we know whether the event we triggered is executed or
Uh, Kafka itself takes that responsibility that whenever we are triggering event, the consumer will consume it if we have configured it in a proper way. So if we have configured it in a proper way, Kafka will take that responsibility that if I have produced some message, Kafka consumer will consume it definitely. If any failures is there, we have to check it in our logs and our monitoring system that something is failing, or we can add some triggers as well on the events. So that is the only way we can uh, check on the failures on the event of events.
Oh, thanks, Kajal.
Thank you. Um, any more questions?
I have one more question. So I have a Node.js application.
Uh-huh.
So currently it is monolithic. So
Uh-huh.
will the conversion of monolithic to microservices is it's related to, like, suppose I want to convert the Java monolith application to Java microservices.
Mm-hmm.
So it's the
Mm-hmm.
same like conversion is for all the languages. I want to ask, like, the conversion will be related to the languages, or it will be independent of the tech stacks, like converting from monolithic to microservice.
It all depends on you. If you want to keep all your microservices in Java, you can keep it in Java. If you want to use different tech stack, you can use the different tech stack as well. So there is no such constraint or hard constraint on the languages. It's up to us. I think Murugan has one more question. Can we get the presentation and
Presentation.
code examples? We can yeah, surely have the presentation and code example. Akash, uh,
Yes, what we can do is like I'll get the presentation and code from Kajal and I will upload that to a OneDrive and I'll share the public link to that code and presentation on the Meetup group after the session is done. And we will make sure like we are doing this for each and every session so that all the attendees can get the code and presentation for their reference for they can download it from the public website, public OneDrive.
okay, I'll send you the git link as well, or
Yes.
should I paste it here?
I think you can paste it over here also, and you can send me that into the email. I'll make
Uh-huh.
sure like I'll organize each and every detail on a single page, and so that everyone can access. But for now, you can paste that here also.
Okay, so this is a Go repo Git project. You can check out here if you want to see anything.
Because initially when she submitted the session to us, and I was very much confused, like what this session is about. I asked her like, is this about AWS? And she mentioned like, no, this is not AWS. This is in general. So I this topic was completely new for me. Yeah, I'm implementing this kind of in like structures in my coding practices in the past, but like I was not aware about like this is the monolith to microservices. So it was a very great experience for me to learn new terminologies, to learn new concepts, and I hope like it was a very good session for you also. I appreciate Kajal, you invested your time, you gave over your valuable time to us and you delivered a session on this very interesting topic. We had a very interesting guest also, like they keeps on asking the question that makes us this session very interactive. So we are looking forward for everyone for our next session. Again, if you are interested in delivering the session, you can please contact us. I'll be submitting the contact detail. Okay, and you will also have an like you will also have a facility to rate this session on Meetup. So please do that whenever you get time, and please be connected on the Meetup group. Yeah, thank you and have a nice day.
Yeah.
Thank you all. Thank you for joining.
Yeah, thank you for joining.
Thank you so much, Kadir and Akash sir.
Yeah, thank you.